says like this one, find all the roots. That means not just the rational roots, right? Not just the real roots, but all the roots, whatever they are. And if we did the rational root theorem, you would say they could be the factors of 8 divided by the factors of 1, which should be the factors of 8. 1, 2, 4, and 8, plus and minus. That's 8 numbers to check. Generally, we're not going to do that. You're going to put it in the calculator and graph it. Let's see if we can see any as x-intercepts really clearly. Most of the time, at least in the problems they give us, you will. All right, so let me go to, that is my number 2. No, that was that. So here's that problem. I've already put it in the calculator. X to the third minus 6x squared plus 6x plus 8. Okay, so look at the graph and tell me if you see any, how many zeros do you see? You see 3. Are any of them, by any chance, like an integer value that shows up? I mean, like this one is clearly between -1 and 0. This one looks like it's between 2 and 3, but that one looks like it might be 4, right? How could you check? Look in the table of values there, right? I mean, in your calculator, because you don't have an emulator, you would go to the second graph. I think I hit that too many times. And just look to see at x equals 4, sure enough, y equals 0. So we did find one rational 0 by doing that. What's that, Peter? Well, since we're not sure what those are, let's use the 0 that we found with synthetic division to reduce this to a quadratic. And then those two will become more apparent once we do that. Right. So let's do, we found with the calculator, from the calculator, right, x equals 4 is 1, 0. So let's do synthetic division with that 0. Here's our coefficients. 1, -6. Come on, stop doing that. -6, +6, and 8. Right? Put a 4 in the bracket. Draw your line. Bring down a 1. Start to multiply. 4 times 1, 4. Add. 4 times -2, -8. Add. 4 times -2, -8. Add. 0. So we already saw in the calculator that 4 was a 0. So if you got to that step and your remainder wasn't 0, you would know you did something wrong, because we know it's a 0. So we got the 0 as a remainder. That's good. What do these numbers represent? Okay, tell me the polynomial. X squared minus 2x minus 2, right? So if there's 2 more zeros, they're coming out of that, right? If they're coming out of that and they're rational numbers, that means that's factorable. So you have to ask yourself, can you think of 2 numbers whose product is -2 and their sum is -2? That would give you +1 for the product. Okay, there are none, which means it's not factorable, which means these last 2 are not going to be rational. So we're going to have to find them with quadratic formula. Okay, so set this equal to 0, and then plug in the quadratic formula for A, B, and C. X equals -2 plus or minus the square root of -2 squared minus 4 times 1 times -2 divided by, I know, I'm going to let my pen catch up here, divided by 2 times 1. Right, that's just plugging in the quadratic formula. Okay, simplify. X equals -2 is +2. Okay, inside the radical, we've got +4 minus -8 divided by 2. So x equals 2 plus or minus square root of 12 divided by 2. X equals 2 plus or minus How can we simplify the square root of 2? Okay, remember that the square root of 12, 12 is not a perfect square, but 4 times 3, you could factor it, and then 4 is a perfect square. So that's 2 times the square root of 3. 2 times the square root of 3. And all of that is divided by 2. So it'll be 1 plus or minus the square root of 3. Now, if you go to the graph again and look, those last 2 zeros, you know, this one is 1 plus the square root of 3, that one is 1 minus the square root of 3. You could turn them into decimals and figure that out. Okay, but notice what kind of solutions are those last 2? Are they rational, irrational, or imaginary? What kind of number is 1 plus the square root of 3 or 1 minus the square root of 3? Irrational, right? It's not imaginary because there's no I, right? An unresolved square root like that is irrational. Can't be represented as a fraction.